So previously we looked at a quadratic, or what's known as, in your lesson, the square function, f of x equals x squared. Now we're looking at f of x equals x cubed. And this is also called the cube function, or cubic function. Our process for graphing it, we're asked to graph f of x equals x cubed, is the same as it was before. We'll substitute in our x values. I went ahead and made a little table here. I listed the x values from -2 to 2. And then we determine what the value of the function is at that x value. So f of -2 equals -2 cubed. And this is one reason it's always important to put your substitutions in parentheses, especially if there's a negative involved. If this out here, the exponent is even, if you put it in your calculator without the parentheses, it'll end up giving you a negative value when it should give you a positive value, because it does the exponent first and then it applies the negative. But if you put it in parentheses, it doesn't. In this case, since we're looking at an odd number, it doesn't matter that if it was in parentheses or not, but it's still good practice. So don't forget to wrap substitutions in parentheses. F of -1 equals -1 cubed, which equals -1. F of 0 equals 0 cubed, which equals 0. F of 1 equals 1 cubed, which equals 1. F of 2 equals 2 cubed, which equals 8. So now we'll fill out our table here. When x is -2, f of x is -8. When it's -1, f of x is -1. When it's 0, x is 0, or f of x is 0 when x is 0. When x equals 1, f of x is 1. And when x equals 2, f of x is 8. So this gives us the points -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. So now we'll plot those points. -2, -8, 1, 2, 3, 4, 5, 6, 7, 8. -1, -1, 0, 0. I'm going to go ahead and change colors here to differentiate where these points and our curve are. 1, 1, and 2, 8. And then we connect them with, as much as we can, or as close as we can, sketching a smooth curve. And there is the sketch of the graph for f of x equals x cubed.